While cooking food, if you leave the metal stirrer in the cooking utensil, you feel it hot when you touch it after some time. Why does this happen? You were not heating the stirrer, but still it became hot. How? Let us find out in this lesson. Objectives. At the end of this lesson, you'll be able to explain effects of heat, identify modes of heat transmission, conduction, convection, and radiation. Explain good and bad conductors of heat. When an object is heated, it undergoes many changes. The object becomes hotter. The object may expand or contract in size. A substance may change its state when heated. For example, water changes into water vapor on heating. We observe a change in temperature on heating. On heating, temperature rises, and on cooling, the temperature comes down. In nature, the sun energy brings about a change in temperature. The days are warm, while the nights are cool. Summer is hot, winter is cold. Matter exists as solid, liquid, and gas. All the three states of matter expand on heating. The expansion of matter depends on the temperature through which it is heated. In this case, when we heat this plate, the higher the temperature, more is the expansion. Expansion of matter also depends on the size of the material being heated. The longer the plate or bigger the bowl, more is the expansion for the same rise in temperature. The nature of the material being heated also plays an important role in expansion. For example, copper expands more than iron for the same rise in temperature. Liquids and gases are fluids. They expand on heating. Expansion in gas is very large as compared to solids or liquids. Let us look at some practical uses of thermal expansion of solids in daily life. The iron rim is fitted in bullock cart wooden wheels by heating. When the metal cools, it holds the segments of the wooden wheel firmly. A small gap is left between the rails of a railway track, where the two rails are joined with the help of a fish plate. The gap is left to allow space for the expansion of rails in summer. Let us now look how heat affects the change in state. On heating, a solid changes to liquid and a liquid changes to gas. Conversely, on cooling, gas loses heat to change into a liquid and a liquid loses heat to change into a solid. The temperature at which a solid melts to change into its liquid form is known as its melting point. Melting point of ice is 0 degrees Celsius. The temperature at which a liquid starts boiling and changing into its gas state is known as its boiling point. Boiling point of water is 100 degrees Celsius. Perhaps you have observed that when a stove is lighted in the kitchen, the air inside the room becomes little warmer. If this air is allowed to come out through an open window, it gradually cools down. The metal stirrer left in the cooking bowl becomes hot. These examples indicate that the bodies at higher temperature lose heat and consequently their temperature falls. When bodies gain heat, their temperature rises. There is a mutual exchange of heat between bodies at different temperatures. Flow of heat takes place in a particular direction, that is, from bodies at higher temperature to bodies at a lower temperature as water flows from a higher to a lower level. There are